doing today? I forgot. Oh yeah, that's right. Spearman's ranked coefficient. We're back down that stat route. So we have talked before, and there are other videos on Pearson's, but this is not the same as Pearson's. Not the same. Now, Spearman's is sometimes used in conjunction with or maybe added to a Pearson calculation to kind of sort of strengthen your argument or add evidence to there being a relationship. But these two things calculate the relationship in two totally different ways. So we know how to do Pearson's, but let's just, as a quick reminder, let's just reflect on what Pearson's was specifically for. So remember, Pearson was specifically designed for data that we may have assumed or thought was linear, that there was a linear relationship between that data. So data might look something like this. As you can see, there's somewhat of a linear trend to this data, right? So much so that we probably could fit a line to kind of predict what our data would do outside of this data, right? Exactly right. So data like this would be perfectly well suited for a Pearson R-value calculation. Now, what if our data isn't necessarily linear? What if our data looks something more like that? Now, clearly, there's a trend here. There's some sort of pattern here. Now, it might not be linear. So if we were to do a Pearson study on this particular data, it might not give us a very strong value, even though it's clearly a pattern there. This data is all pretty much going up. There's a monotonic trend to this data. It's either all going up or it's all going down. So there's got to be another way to calculate the value of this relationship. You know what we got? Spearman's. So Spearman's is to find out if there's a relationship within data that might not be linear, right? So to do that, we're going to rank our data. As with most math, better by doing. Let's try one. Okay, bang. So here's the situation. We have two judges, and these judges are judging a diving contest. And so what we have are our judges' scores for each of 6 divers. So judge number 1 and judge number 2, these are their 2 scores for each diver's dive. So we can do a Pearson's value calculation on this to see if there's a relationship between this data, but I'm not necessarily sure that this is linear. And even if it is, maybe it would be worth our while to add some evidence to our argument by doing a Spearman's also to see if there's an overall trend, that there's an agreement or not between these judges, right? Okay, so that's our goal here. Our goal here is to rank these, to find a Spearman's rank coefficient to see if there's an agreement, any sort of agreement between these judges' scores. All right, so let's do it. These are the judges' original scores. Now what we're going to do is we're going to take each of these scores and we are going to rank them. Looks a little bit like this. So it would be really, really beneficial and helpful to set up a completely new array for your rankings. So what we're going to do is we're going to go down each judge's scores and we are going to rank his scores with ranking number 1 going to the highest score for that judge. Okay, so judge number 1, his highest score, 8. So I'm going to replace that 8 with 8's ranking. If number 1 is the highest score, I'm going to give that score of 8 a 1 ranking. Good, very, very good. Okay, so what's next? We have 2 7s, there's a tie. There's a tie for second and third. There's a tie, so what do? They share the 2 rankings that they would occupy. So if I already have first place here, my next 2 rankings would be ranked second and third. So what's the average of 2 and 3? Good, exactly right. So these 2 7s that are tied for second and third share that second and third ranking, so we give them an average of second and third. An average of 2 and 3, 2 plus 3 divided by 2, 2.5. Good. Okay, so now if we taken up ranks 2 and 3, we're on rank number 4 now, correct? Okay, so what number comes next? 6 is the next highest score. Rank number 1, ranks number 2 and 3, so we're on rank number 4. Exactly right, exactly right. So now we're going to pick up with ranks 5. As you can see, we got another tie. So that tie is for ranks 5 and 6, right? So they're going to share that ranking by averaging ranks 5 and 6. Bang, just like that. So now we are done ranking the first judge's scores. Number 8, getting the first rank, because that's the highest score we have. Now, after 8, we have a tie for second and third. So what we did was we averaged those rankings. Second and third average at 2.5. So now that we have ranked second and third taken up, we're on ranking 4. 6 comes next. 6 gets a 4 ranking. So now we're at rankings 5 and 6. Tie for 5 and 6, ranking 5.5. Okay, now we're going to do this exact same thing for the other judges' scores. Here we go. Okay, so we're going to do exactly the same ranking process for the second judges' scores. So highest score gets a number 1 ranking. So highest score here is a 9. 1. Exactly right. So now what comes next in the highest scores? I got 3 8s. I got a tie, a 3-way tie. I got a 3-way tie. So remember what we do in the case of a tie. We take their rankings and we average them, no matter how many there are. Before it was only a 2-way tie, now it's a 3-way tie. What rankings are we talking about here? After 1, we're talking about rankings 2, 3, and 4. Rankings 2, 3, and 4. What is the average of 2, 3, and 4? Bang! Exactly right. So in a tie, they share the rankings by averaging the rankings that we would have used. So these would have been rankings number 2, 3, and 4. So I averaged those rankings to get an average ranking of 3 for all of them. Good. Okay. So now that we have taken up rankings 1, 2, 3, and 4, we are on ranking number 5 now. Exactly right. What number comes next? 7 comes next, gets a ranking of 5. Good. Now remember, ranking 1, rankings 2, 3, and 4, but they all share a ranking of 3 because they're tied. And so ranking 5 comes next. When you think about it, it makes sense because we have 6 numbers, so we should have 6 ranks. The last number, the lowest number is 5, rank 6. Good. Now that we have these rankings, what we're going to do is a Pearson study. Ha! Yes, but a Pearson's value calculation, we would have entered these values for a Pearson, but to do a Spearman, we put in the ranks instead. Pearson original data, Spearman rank data. So now, whatever method we use, calculator or the spreadsheet way, we're going to enter these values to do a Pearson's calculation on ranked data to get a Spearman coefficient. It's going to look something like this. Okay, so quick recap. Original scores and original data. If we were to put these into our Pearson calculator, we will find out it's an R value of about 0.839. So that's right on your borderline of strong, depending on what your cutoffs are. So it's sort of linear, but maybe not. So let's see what Spearman has to say. Bang. Now, the difference between Pearson and Spearman is this subscript of S. So it's still an R value that we're calculating. It's still a strength of a relationship, a strength of an agreement. But this is S for Spearman because we are calculating for this value ranked data. And as you can see, there's a stronger agreement when we take out the idea that it's linear. So there's a trend here, a very, very strong trend here. It might not be a linear one, but it's a very strong trend here. We use these in conjunction to add evidence to our argument if in fact there's a relationship or an agreement between these judges' scores. Now, to answer one question, it does not matter if you choose number 1 to be the highest score or the lowest score. You can rank your values any way you want to. Just be consistent. If you want to rank them lowest to highest, it's totally fine. Just make sure you rank both judges, lowest to highest. Thanks for checking me out, man. Let me know if you have any questions. Next time. Bye.